Good afternoon, everyone. My dear students, we are going to discuss a very important topic in organic chemistry. That is the isomerism in organic compounds. Before we go for the topic specifically, how many of you know what are isomers or isomerism? Actually, isomerism it's a phenomenon in which we have uh, a number of compounds under the same molecular formula. That means, suppose we have a butanol or butanol. These two compounds are having same molecular formula, but their structures are different. So there are two compounds under the roof of the same molecular formula. So isomerism is a very important concept. Every one of us should know about it before we have before we have a before we want to have a very good knowledge in chemistry. Uh, Actually, isomers, they if we want to classify them, isomers, they are basically of two types. One is structural isomers, then another is stereoisomerism. The concept, the phenomenon is isomerism, and the compounds are called as isomers. So now, okay, let's move on to the classification of the isomers. Basically, isomers are of two types: constitutional isomers and stereoisomers. Constitutional means constitution, means structure. Their bonding pattern, how the atoms are bonded to which atom, how many atoms are there of a particular type of atom. So these will be constitutional aspect of the molecule. Then stereoisomers means, actually they are also called 3D isomers. 3D isomers, it will be the arrangement of the atoms in space. That is, 3D means space. In space they will be different. These stereoisomers, if we want to classify, we will go to this later on, but before we go to stereoisomers, let's have a very brief look on constitutional isomers or structural isomers. Structural isomers, yes, they, as per IUPAC, they are called constitutional isomers, structural isomers, which have the same molecular formula, but the bonding pattern, the how the atoms are bonded, they will be of different orders. Then the different types of structural isomers, if you go, yes, number one, it is chain isomers. Chain, from the name itself, it is clear that the molecule will be different. How? Due to the molecular formula same, but the same structure, the composition, the morphology in terms of the same structure will be different. Like in this compound, suppose this is pentane. This is n-pentane, no side chain, the straight chain compound. This compound is what, having one chain, it is 2-methyl butane. The same molecular formulas, 5 number of carbon atoms and 12 number of hydrogen atoms, and in the last one it will be 2,2-dimethyl propane. So here also it is what, 5 carbon atoms and 12 hydrogen atoms. So three different compounds. Where do they differ? Actually they differ in the chain composition, say the morphology, the chain structure. So they are called chain isomers. Then it is position isomers. Position isomers, from the name itself, it is evident the functional group. Actually, it happens to be in case of the compounds where we have functional group. Suppose, as clear in the examples, it is in the propane. This is propane 1, the OH group is in the very first carbon. Then it is propane 2 in the second carbon, and it is a different compound where the weights, it is actually it is not a position isomer. This and this actually they are position isomers. This and this, it will be a separate class of isomer, that will be your functional isomer. Why? Because this is OH group and this is O. That means these two are alcohol and this is ether. The same molecular formula, but the difference is in the functional group. Where it is an alcohol, it is an ether. So the next one, it is functional isomers. So what are these functional isomers? Functional isomers are those in which we have different compounds under the same molecular formula but differing in the nature or type of the functional group. Then we have metamerism. Obviously, it happens to be in case of compounds where the functional group is bivalent means it has two valence means it has two attaching sides. Suppose in ether, the oxygen atom is in between. Here also it can be an alkyl group, and here also it can be an alkyl group. So if the distribution of the alkyl groups around the two sides of this O atom differ, then they will be metamers. Molecular formula will be some here, like in this case it is number 1 2, so it is ethoxy-ethane, and here it is methoxy-propane. So number of carbon atom is 4, but the compound is different due to what? Due to the distribution of alkyl group in around the functional group. Then there exists tautomerism. Tautomerism or tautomers, they are actually a separate class of isomers in which there exist two compounds which are in dynamic equilibrium. We actually cannot isolate them separately easily, but they exist in equilibrium, means one form readily converts into another, and the difference is in between an H atom, attachment of an H atom. Suppose in case of a very famous tautomer like keto and enol, so in keto form there will be a C double bond O, and here in enol form it will be COH. So the H atom here, it goes to this O, and the double bond converts into the single bond. So these two compounds, they are in rapid equilibrium. That means one converts into another in the room temperature. So this type of functional isomers, actually they are functional isomers where it is a ketonic group and here it is an alcoholic group. They exist simultaneously in dynamic equilibrium. So this type of isomerism is called as tautomerism. So I think we have got a very what I should say basic idea about the constitutional isomers, and then we will move on to the stereoisomerism. Stereoisomerism, as I have already mentioned, stereoisomerism, actually the isomerism related to stereo means space, 3D isomerism, and it is very important in terms of especially in biological, pharmaceutical, in physical, and in supramolecular chemistry, because suppose if we go for the pharmaceutical industry, many of the drugs, drugs and what I should say, suppose disease identifying agents, compounds, organic compounds, they are the stereo one. If one stereoisomer has one property, have the capacity of relieving one type of disease, the another stereoisomer may not have that capacity. So this stereochemistry or the chemistry of molecules in space, because why I am saying this this molecule of chemistry of molecules in space, because here the structure will be same, the molecular formula will be same, but only thing which will be different is the relative arrangement of the different atoms in space. Just like here, it is, if we find it is suppose the blue one is nitrogen, here the nitrogen is in the right hand side while the nitrogen atom is in the left hand side. One is the mirror image of the another. So these types of things will delve in a separate class. So before I finally thank you, let me tell you about the utility of this video. This video will be for those students who have this year been admitted in the higher secondary classes, and of course some undergraduate students might also be might also get some importance in this video, and of course I'll be releasing more videos on delving on different aspects of stereoisomers. And thank you all for your patient hearing. Thank you.